Red Bull sells over 9.8 billion cans annually worldwide. But have you ever wondered what actually goes into each one? The ingredients list mentions taurine and glucuronolactone, but most people have no idea what these substances are or where they come from. In this exclusive documentary, we take you inside Red Bull's closely guarded production facilities to reveal the surprising truth about how this global energy phenomenon is manufactured. From the precise chemical formulations to the high-speed production lines that fill 1,500 cans per minute, you're about to see what happens behind closed doors. Welcome to the raw ingredient storage facility, where Red Bull begins its journey from basic components to iconic energy drink. This cavernous space houses giant stainless steel tanks and climate-controlled containers, each holding the precise building blocks that will eventually fill billions of slim cans worldwide. The air here is highly regulated, with temperature and humidity controls ensuring ingredient integrity from the moment they arrive. Let's start with perhaps the most misunderstood ingredient, taurine. Despite persistent rumors circulating for decades, taurine in Red Bull has nothing to do with Bull's anatomical parts. While its name does derive from taurus, the Latin word for bull, as it was first discovered in bull bile, the taurine in your Red Bull can is entirely synthetic. Manufactured in pharmaceutical facilities, this amino acid appears under microscopic examination as geometric crystalline structures that resemble delicate snowflakes. What's fascinating is that taurine doesn't actually function as an energy stimulant as many assume. Instead, it works to inhibit excitatory neurons in the brain, essentially providing a calming effect on the nervous system. Quite the opposite of what most consumers expect. Moving through the facility, we encounter the caffeine storage area. Unlike coffee shops that extract caffeine from beans, Red Bull uses synthetically produced caffeine that arrives as a fine white powder resembling baking soda. This powder requires extraordinarily precise measurement systems. Variations of even a few milligrams could alter the drink's effect profile. The production staff handles this ingredient with particular care, as consistency across billions of cans demands pharmaceutical-grade accuracy. The B vitamin storage section reveals another critical component of the Red Bull formula. These concentrated vitamin compounds, niacin, B3, pantothenic acid, B5, B6, and B12, arrive in sealed containers and require careful dilution. These aren't just arbitrary additions. They're calculated to support energy metabolism, help construct immune barriers, and regulate nervous system function. The ratios differ slightly across global markets due to varying regulatory requirements, requiring separate formulation protocols for different regions. Behind reinforced doors lies what might seem mundane, yet forms the foundation of every can: water storage and treatment facilities. Sourced from the pristine Austrian and Swiss Alps, one of the world's largest freshwater basins, Red Bull's water undergoes multiple filtration stages. This near-obsessive purification process ensures consistent mineral content across every production batch. The alpine water, naturally replenished in abundance, travels through a series of increasingly fine filters, UV light treatments, and mineral adjustment systems before it's deemed worthy of becoming the base of the world's leading energy drink. The sweetener section is equally impressive, with separate facilities for regular and sugar-free varieties. Each sweetener undergoes spectroscopic analysis and density testing before being approved for production use. For the original formula, specialized sugar crystals are measured for precise dissolution rates that affect both taste and mouthfeel. The glucuronolactone storage area might house the most enigmatic ingredient of all. This naturally occurring compound found in connective tissues gets significantly less attention than taurine, but serves important physiological functions. Like taurine, the glucuronolactone in Red Bull is synthetically produced rather than animal-derived. Quality control stations throughout the facility continuously sample each ingredient, with technicians in white lab coats performing both automated and manual testing. Digital displays monitor everything from microscopic impurities to chemical composition, ensuring nothing reaches the mixing stage without meeting exact specifications. Once the meticulously tested ingredients pass inspection, they enter an industrial wonderland where engineering precision reigns supreme. Behind massive steel doors lies a network of gleaming tanks and specialized equipment representing the pinnacle of beverage engineering, a system so finely calibrated that it can detect irregularities smaller than a human hair while producing enough Red Bull to satisfy the world's thirst for energy. These massive stainless steel mixing tanks form the core of Red Bull's production process, connected through an intricate network of pipes that snake throughout the facility. Industrial pumps push ingredients through this metallic maze with digital systems maintaining exact flow rates. Nothing here happens by chance. Every valve, every sensor, every measurement exists for a specific purpose, creating absolute consistency in every can. The mixing process follows a precisely choreographed sequence. First, purified water and sugar combine in primary tanks, creating the base solution that will eventually become Red Bull. Engineers monitor digital panels displaying real-time data on mixture density, temperature, and dissolved solids. Only when these parameters reach exact specifications does the system allow the next phase to begin: the introduction of acids, taurine, caffeine, and other active ingredients in carefully timed intervals. Temperature control systems maintain optimal conditions throughout this process. Cooling jackets surround the tanks, filled with glycol solutions that can rapidly adjust the mixture's temperature within fractions of a degree. This precision matters because certain compounds in the Red Bull formula become unstable or change properties when exposed to higher temperatures, which could compromise the final product's taste profile or effectiveness. Next comes carbonation, the element that gives Red Bull its signature effervescence. In pressurized tanks designed to withstand multiple atmospheres of pressure, carbon dioxide gas is injected into the liquid under carefully controlled conditions. Engineers must balance pressure, temperature, and contact time to achieve the exact level of carbonation. Too little, and the drink feels flat. Too much, and cans might rupture during packaging. Throughout this entire process, automated quality control stations continuously sample the product as it moves through different production phases. Sophisticated analytical instruments measure pH levels, sugar content, carbonation pressure, and ingredient ratios in real time. If any parameter deviates from established standards, the system flags the anomaly, and production engineers make immediate adjustments or, if necessary, divert that batch for reprocessing. After complete mixing and carbonation, the liquid travels through a flash pasteurization system, a crucial safety step that many consumers never consider. This technology heats the liquid to a precise temperature for just milliseconds, long enough to eliminate any potential microorganisms, but brief enough to preserve the drink's carefully balanced flavor profile. Thermal sensors monitor this process within 0.1 degree precision to ensure product safety without compromising taste. This pasteurization stage serves two critical purposes: eliminating potential contaminants while extending the product's shelf life. The process must be meticulously controlled. Just a fraction of a degree too hot or a millisecond too long could alter the properties of key ingredients, changing the distinctive taste that Red Bull drinkers expect. The manufacturing technology driving all these processes represents decades of engineering evolution. When Red Bull first launched in 1987, production relied on semi-automated systems with significant human oversight. Today's facilities operate with fully computerized production lines that simultaneously monitor over 100 different parameters, from pressure differentials in mixing tanks to microscopic variations in ingredient flow rates. Modern Red Bull factories represent an almost perfect marriage of food science and industrial automation. The digital precision of Red Bull's production extends far beyond the mixing phase. Now, the perfectly formulated liquid faces its most critical transformation, becoming the finished product encased in that immediately recognizable slim can. Few people realize this distinctive packaging, which has become synonymous with the Red Bull brand, created one of the company's greatest manufacturing challenges. Empty aluminum cans arrive at the facility by the thousands, carried along high-speed conveyor systems into what resembles a medical cleanroom more than a beverage factory. The air quality in this environment is maintained at standards that exceed many hospitals, with advanced filtration systems removing particles as small as 0.3 microns. This exceptional cleanliness isn't merely for show, it's an essential factor in maintaining product integrity and preventing contamination. The slim can design that made Red Bull instantly recognizable worldwide nearly derailed the entire production process in its early development. Standard beverage canning equipment simply couldn't accommodate the unique dimensions of Red Bull's slender container. Engineers had to develop completely custom filling machinery, unlike anything seen in conventional beverage factories, requiring significant investment and technological innovation to perfect. Before any liquid touches them, each can undergo intense scrutiny. High-speed cameras positioned strategically around the conveyor capture images of every empty container, analyzing them for microscopic defects that would be invisible to the human eye. These sophisticated imaging systems can detect imperfections smaller than a human eyelash, a damaged rim, Microscopic puncture, or even the slightest contamination inside the can results in immediate rejection from the production line. The surviving cans then enter what engineers refer to as the critical zone, the filling station. Here, in a pressurized environment, each can is first purged with nitrogen gas to displace oxygen, preventing oxidation that would affect taste and shelf life. The precisely formulated liquid then flows into each container at carefully controlled rates. This isn't simply pouring liquid into a can. It's a precisely engineered process where flow dynamics and pressure differentials ensure consistent fill levels across thousands of units per hour. Once filled, specialized seaming machines apply the pull tab lids with micrometer precision. These machines create a hermetic seal through a two-stage operation that rolls and compresses the edges of the lid and can together. The resulting seam must meet exact specifications measured in thousandths of an inch to maintain carbonation and prevent contamination. A perfect seal ensures the beverage maintains its signature effervescence from production until the moment a consumer opens it. The quality verification process continues relentlessly. Each sealed can passes through multiple checkpoints, including weight verification stations that can detect variations as small as 0.5 grams. Sophisticated seal integrity testing equipment applies pressure to the sealed cans to identify microscopic leaks, while advanced visual inspection systems capture 360-degree images to detect any external imperfections in the finished product. Before leaving the production area, laser coating systems mark each can with production data, lot numbers, and expiration dates. This seemingly simple step serves a crucial purpose, creating complete traceability from factory to consumer. Should any quality concerns arise, these codes allow Red Bull to identify exactly when and where a particular can was produced, facilitating rapid response and maintaining consumer confidence. The manufacturing line transforms raw ingredients into the finished product through more than 30 distinct production steps. Each phase is monitored by multiple quality control systems working in concert to ensure absolute consistency. The cans are then automatically packed into cases, stacked onto pallets, and moved to temperature-controlled storage areas to await distribution. Wonderful. From these storage facilities, Red Bull's sophisticated global logistics network takes over. Temperature-controlled trucks and specialized shipping containers ensure the product reaches distributors worldwide in optimal condition. The company's logistics team carefully manages shipping routes to minimize time in transit and reduce environmental impact, employing advanced tracking systems to monitor shipments across the globe. As our journey through the Red Bull manufacturing process comes to an end, we've witnessed an intricate symphony of technology and precision that few consumers ever consider. Behind that slim aluminum can lies a global distribution network that spans more than 171 countries, requiring sophisticated logistics to maintain product integrity worldwide. Unlike other beverages that share fundamental production steps, Red Bull has engineered unique solutions to its manufacturing challenges. Even their sustainability efforts reflect this attention to detail, with 100% recyclable lightweight aluminum cans and energy-efficient facilities demonstrating that innovation extends beyond the formula itself. The next time you experience that familiar carbonated taste, remember it represents not just a drink, but an achievement in modern food technology